All right, guys, so here's the answers to target 48. Again, make sure you take notes. So the target is on graphing quadratic functions. Remember, to graph things, we can make a table of values. But when we graph quadratic functions in particular, we need to find the key points, which for the main part is the vertex. So what I can do is I can fill out this table here using order of operations. If I put 0 in for x, I'd square it first to get 0, times a fourth is 0, and then subtract 5, and I would get negative 5. Doing the same for 1. 1 squared is 1, times a fourth is a fourth, and a fourth minus 5 is negative 4.75, or negative 4 and a fourth. If I square 2, 2 squared is 4, times a fourth is 1, 1 minus 5 is 4. If I do that for negative 1 and negative 2, remember when you square negative numbers, like squaring negative 1, you get positive 1. So you're going to get the same thing here as you did on the other side. So now graphing those points, we've got 0, negative 5. And then I'm just going to graph the, these should be negative 4. The 2, negative 4. And the negative 2, negative 4. And if you want to graph more, you can, but that's enough here. We can then see that it's going to be a parabola opening up from there. All right?
Yeah.
Number 2. This one they asked specifically to label the vertex and the axis of symmetry. So I'm going to start with that part. Remember, to find the axis of symmetry, we use this formula. X equals negative b over 2a. So if I look at this, a is negative 3, b is 5, and c is positive 3. So it would be negative 5 over 2 times negative 3. Do that multiplication in the denominator first. You get negative 5 over negative 6, which is 5, 6. So the axis of symmetry is the line with equation x equals 5, 6. You have to have the x equals there. If you put x equals 0.083 or rounded that off, that's okay as well. So it's just shy of 1. Now I like to draw in the axis of symmetry. It's a vertical line that divides the parabola into a left and a right side. That's why you have to have the x equals in there, because it's an equation of a vertical line. Now what I know is that the vertex is going to lie somewhere on that point, or on that line. So the x-coordinate of the vertex is going to be 5, 6. Now to get the y-coordinate, what I'm going to do is I'm going to plug in 5, 6 in place of the x values in that equation. That's my original equation. And you could use a calculator to help you with that. If you use the decimal approximate, I would just keep that as 0.083. I wouldn't try to round that off too much. So I'm going to take negative 3, 6 times 5, 6 squared. Notice how I use parentheses. Plus 5 times 5, 6 plus 3. And if you used 5.083 for your y-coordinate of your vertex, that would be fine as well. I'm going to leave it as a fraction, so I'm just going to convert that to a fraction. And I get 61/12. That must be 5 and 1/12. So now that, I can tell, is going to be on this line up 1, 2, 3, 4, just a hair above 5. Okay, so now to graph some other points, I need to make my table. Now remember, you can pick the x values for your table. So Like an easy one to pick would be 0. If I put 0 in for both x's, I'd get 0 plus 0 plus 3. So I'm going to plot that point. 0, 3. If I put 1 in for the x's, I get negative 3 plus 5, which is 2, plus 3, which is 5. So I have the point 1, 5. If I put 2 in there, 2 squared is 4. 4 times negative 3 is negative 12. So I'd have negative 12 plus 10 plus 3. I believe that's 1. You can also use your calculator if you'd like to, to get some of these, just like I did before. If I want to put in negative 2, just use parentheses, negative 2 squared plus 5 times negative 2 plus 3. So I get negative 19 for negative 2. So I'm already off the chart there. If I put 1 in there, I'd get, if I put negative 1 in there, I'm going to get negative 3 plus negative 5 plus 3. So that would be negative 5. Is that right? And another way I could do all this by checking is I could type in my equation in my y equals negative 3x squared plus 5x plus 3. And I can look at a table. So another point I could get there is 3 negative 9. That might be worth plotting. Over 3 down 9. Okay, so now I get the idea of what this parabola looks like. So I just connect those together to form a nice parabola. All right, so make sure you've labeled your vertex as a point. You've labeled your axis of symmetry as a line in x equals equation form. You've shown a table of values, and you've plotted the points to draw an accurate graph. And the graph should have the vertex on there. That's why we find it. All right, number 3 is a real simple problem. It's just asking what would we do with the graph of y equals x squared. Remember, that's the parent function. It's a graph with a vertex at 0, 0. What does the plus 1 do to the graph? It would just shift that vertex up 1 unit. So the way I would describe this as a transformation, you're sliding the graph up 1 unit. We call a slide a translation, up 1 unit. So it's basically like you're just picking up that parabola and sliding it up 1 unit. All right? And then the last one for target 48 is this word problem where we're given a function that describes the height of an object or rocket flying through the air. The 5 is the initial height, the 128 is the initial velocity, and the negative 16 in the equation comes from gravity. So they've already graphed it for us, but what they're asking here is to find the time and the height when this rocket reaches its maximum point. Well, I can kind of see that right here, and it looks to be around an x-coordinate of 4 and around a y-coordinate of about, 260 or something like that. But I want you to do better than just estimate those from the graph. I want you to find them precisely. So that's where we find the x-coordinate by doing the x equals negative b over 2a. That's going to give us our axis of symmetry. So b is 128 from the equation. A is negative 16. And if we divide those, we will get 4. So in this case, if you were just to estimate it from the graph, it would look pretty much right on. But be careful there. Actually do that work because it might be a decimal. It might be like 4.2 or something. So that's the time when it reaches its maximum. The units for that are in seconds. That's the x-coordinate of the vertex. So now to find the y-coordinate of the vertex, which represents the height of the rocket at that time, we just substitute the 4 in place of the t, in place of both t's in the equation. And you can type that in a calculator, and if you do, you will get this, 261. So that is the maximum height of the rocket. Now again, if you had just estimated it, you might have estimated 260 or something, but I want you to be very precise with that. So that's why you have to use the equation. You won't get full credit if you had just rounded or estimated to 260. And again, the units for that are feet. So then, to answer the last question there, state a practical domain in range. A practical domain in range are a domain in range that fit this practical situation. In theory, the parabola goes down and out forever. So its domain would be negative infinity to infinity. But in this practical problem, it really only makes sense for this part of the parabola. It stops and ends here. So the practical domain is those time periods. It's a minimum time of 0, and then the maximum time, since this is the axis of symmetry, it takes 4 seconds to get to its highest point. It's going to take another 4 seconds to get back to where it started. Maybe a little more. Actually, it might even be a little more than that. We should probably investigate that a little more. It's going to be around 8 seconds. The practical range, I suppose the smallest, it starts at a height of 5, but the smallest it really will ever get is 0 feet. And we have found the maximum it will ever get is 261 feet. Okay? So, if I want to get a little more precise answer for that high number for the domain, I could solve this equation. And I could, here we go. I could use the quadratic formula to find out when this equals 0, when the height is back at 0 and the rocket is on the ground. So that's where I would do my negative b, which would be negative 16. Plus or minus the square root of b squared, whoops, I'm sorry, that's not b. It would be negative 128. Plus or minus, I'm just going to do the plus here, the square root of b squared minus 4a times c. That's my whole numerator, all divided by 2a. And I'm predicting this will be a little over 8. Oh. No. Let's try the minus here. Must have something in there wrong. There we go. So there's the minus answer. The negative answer doesn't make sense. So the maximum time that makes sense in this problem is the time it takes for it to hit the ground, which is when the height is 0. So it'd be about 8.04 seconds. If you want to get close to that, I'm not going to get super picky on that because that's a different target finding that. If you take the distance it takes to, or the time it takes to get to the highest point, 4 seconds, and double it,